Here's now a little discuss after those applications. Let's discuss sensor clouds in a little more detail. So here's the idea of a sensor cloud. You have all your sensors. They're publishing their data to the cloud. And so because they are actually erratically publishing data, each of those data is by definition an event, then it's natural to use event processing software, and then we so-called publish subscribe software. So the basic idea of the architectures we have for this type of problem is a network of distributed publish subscribe brokers, which then gather where sensors publish the data to the brokers, and then the filters, the transforms, the transformation agents are going to take the data from sensors and turn it into information and knowledge. They subscribe to the sensor data they want, and then they produce refined data, which is then notified back to either desktop clients or to particular applications and so on. And this I should point out, this is naturally collaborative, because once you've centralized all these sensors in the cloud, we can actually be notified all sorts of different applications, so you can get natural sharing of this data. This underlies effectively the architectures of activities like WebEx or Adobe Connect, where say the host is presenting on their PowerPoint, that PowerPoint is transmitted up to the cloud, and then it's notified back to all the people sharing that information. There's been a change, and that change then appears on your desktop. Here's that architecture in a little more detail. We originally used some software we wrote ourselves called Narada Broking to do the publish subscribe. Now we use well-known open source software like ActiveMQ or Netty to support this idea. When we did Narada Broking, these were in early days, and we used the fact that we wrote our own software to support particular protocols, such as those needed to do audio-video conferencing and provide the optimized support. So as well as the distributed broker, we're doing the control. We also have the data effectively being done separately, and this is an important idea when you do these web services. You make certain that you send the data to something which has the bandwidth to process it. And you can usefully separate control and data services. You also need to be able to do a lot of management. You need to know how many sensors you have, what their properties are, and provide a nice interface so people can probe the system and see which sensors they want. Here's some old examples we did with a company, Anabas, where we have multiple Lego robots with various sensors on those robots, and then including the RFID and the GPS. Those will all sent back to the cloud and plotted out as you can see here, and then use the GPS to locate this the position of these sensors. These particular things are from Hong Kong, which is what you see the location as. When you look at the performance of these brokers, here we were looking at high-end sensors, roughly equivalent in bandwidth to an MPEG-4 webcam, or the Connect, which is around 1.8 megabits per second for each instance. That's pretty high bandwidth. Then here was as you looked at the number of clients, we had the sensors hosted on OpenStack using virtual machines. And you can see that basically the latency is relatively small, till around 150 clients when it gets a little out of hand. So you can, if these very high bandwidth clients, you can put 100 on a broker. That doesn't mean you can only have 100 sensors. It just means a single broker can only handle 100 sensors. All of these publish subscribe systems allow you to use multiple brokers, and they establish the appropriate management to allow the brokers to coordinate with each other.